Hello everyone, today we will talk about logistic regression. Logistic regression use logistic function, or we say that as sigmoid function, and its formula you can see here, 1 divided by 1 plus e to the power minus t, and this t is a linear equation. So if I would want to establish a relationship between linear regression and logistic regression, then I would say uh, equation in linear regression is y equal to mx plus c, and when we put that y equal to mx plus c here in place of t, then we get logistic function. So value of logistic regression always lies between 0 to 1. So it's used for classification problem, for example whether customer will buy some insurance product or not. So 1 if I would say yes, and 0 if I would say no, then using this logistic function, we calculate this value, and if this value lies more than 0.5, then we can say yes, and less than 0.5, then we can say no. So basically logistic regression is used for classification problem. So one thing to note here is that output, that is dependent variable, in logistic regression is always discrete variable. However, independent variable, that is input variable, can be discrete or continuous. Just to understand why we need logistic regression, why some problem cannot be solved using linear regression. So these two chart I have brought from internet. So left hand side you can see uh, there are 6 data points, 3 on 0 side and 3 on 1 side, and then using linear regression some line has been drawn, this particular line, and you can see if I would decide a cutoff and I would say this line. So on this line, if y greater than equal to 0.5, then we can say it's yes, that is 1, and y less than 0.5 we can say 0. So here you could see 0.5 is here. So if I will go this way, so anything right to this line, so all these three is 1, and all these three left to this particular line is 0. So this way linear regression is working fine here in this case of classification problem. But a slight change in data, composition of data, makes situation more tricky. So now you can see on one on positive side, one, we already had 3 data set, and then this one which is right to these all previously existing 3 data sets. So this is kind of I could say outlier. Now we tried to draw a straight line. So this is the straight line uh, which will come after linear regression. So if we will decide cutoff 0.5 here, then you could see anything left to this line is 0 and right to this line is 1. So right to this line only one data set false, which is 1, that's okay, but left to this line, this vertical line, you could see these 3 data set also false. So ideally, this should be 1, but our linear regression model will predict this as 0. So that's why linear regression model doesn't work in case of classification problem. Other thing is also that linear line equation gives value up to infinite. So that cannot be in the range of 0 and 1. But logistic function always gives value in the range of 0 and 1. So which suits more to the uh, classification problem. So here I have tried to create a dummy data set with 20 rows, and I have drawn a straight line, and function of that straight line I have put to the logistic function, and I have drawn this logistic equation, sigmoid function. I will tell you what data exactly is. So here on x-axis, x value I have taken 1 to 20 in serial 1, 2, 3, 4 till 20. Y I have placed a equation y equal to m is 2 here. In this case m is 2. So y equal to m x, that is this one x-axis, plus c I have taken minus 20. So this column B in this Excel worksheet is linear regression, equation of linear regression, or I can say equation of line. Now this logistic function in this logistic underscore y, so this column I have taken 1 divided by 1 plus exponential of this column B. So this way in this logistic function I have passed that this particular value and then I have compared. So as previously mentioned, so line equation for logistic regression is 1 divided by 1 plus e to the power minus t, where t is equation of the line. So same thing I have done here in 1 divided 1 plus e to the power minus t. So this is t, that is equation of the line. So this particular chart is about plotting this line y equal to mx plus c, and you could see value is ranging between minus 18 till 20. So this is straight line, value is ranging high. Now I have plotted this logistic underscore y, and you could see values ranging between 0 and 1, and this is pretty similar to this graph, which is graph of logistic function. Now let's jump to the practical part. So here I have important functions, important packages, numpy for creating arrays, pandas for data frame, and matplotlib uh, for plotting purpose. And this matplotlib inline, present matplotlib inline is syntax for having figures on this Jupyter notebook itself. So I will execute this part of the code. Now in DF I have imported my data sets. In data sets I have some informations related to a social network advertisement, and uh, so data set is like we have 5 columns. We have user ID, we have gender, we have age, we have estimated salary, and then we have whether insurance is purchased or not. So this particular I am importing here, and then I want to see how this data looks like. So soon result will be here. So we can see how data looks like. We have user ID, and then we have gender, we have age, we have estimated salary, and we have purchased or not purchased. Now using info function, just want to see whether it contains null value or not. So you could see no null value for all these, so we do not need to do any null value treatment here. Now next is we need to do some data cleaning steps in order to make data appropriate for our model. So this thing we'll do now. You could see user ID is no use for any prediction algorithm, because user ID is always different for different user, and so one user ID will have only one value, so it's of no use. So we'll drop user ID from our data set. So what I have done is, name of the original data was df, so I have created df underscore new, and I am dropping user ID. So df, which is old data set, dot drop is pandas function. then user ID, and x is equal to column. So this way I am dropping this one. Now you have how data looks like. So now you can see user ID has been dropped. We have four columns only: gender, age, estimated salary, and purchased. So using these four columns, we'll try to create models. So before creating models, again, we need to divide this data set into input and output, that is uh, independent variable and dependent variable. So output is purchased and input is these three columns. So X I have considered as input, and in X I am taking everything from df underscore new except purchased. So df underscore new dot drop purchased x is equal to column. So this way I am taking everything except purchased. Now for output I am taking y equal to df new dot purchased. So this is output vector, and x is data frame and y is vector. Now if I will show you how x looks like and how y looks like, then if I will do x dot head, so top 5 rows of x you will be able to see here. So here you could see we have in x we have gender, age, and estimated salary. Again, if I would want to show you y, then you could see in y we have this thing 0 or 1. So this was the x and y, that is input and output separation from original data set. Now one more important thing is creating dummy variables. So as you know, our machine learning models work on principle of estates, and for estates, for calculating anything we need a number and not the alphabets. So this gender is categorical variable which has two values, male and female. It's not numerical variable like age, estimated salary. So what we'll do, we will create dummy variable as we had done in case of linear regression. So I am creating this data frame gender underscore dummy using pandas function get dummies. So pd dot, this is the syntax, pd dot get dummies. Pd, since I have imported panda as pd, import panda as pd in the beginning of this code, you can see here import pandas as pd. So that pd I have referred here dot get dummies. I am passing x data frame, gender column of x data frame. So till here my work is done. Drop first dot true is just to avoid dummy variable trap. So that thing I will again explain here. But before that, let me execute the code and I will show you how data looks like. So you can see here we have only this thing male, and value is 1 for some rows and 0 for some rows. So again coming back to this thing, if I will not do drop first true, then what will happen? Now see how my data looks like. So it's female and male. So what this particular thing is doing is that dropping first column. So whatever uh, getting created after pd dot get dummies function, applying pd dot get dummies on this input. So first column is getting dropped. This is why, because this is to avoid dummy value trap. So what happened? We have this, for this gender we have male or female. Now if I will tell you value of male is yes, then you can say okay, value of female is no. And if I will tell you value of female is no, that is 0, then you can say okay, value of male is 1. So by knowing if you have n categories for any categorical variable, n categories, here n equal to 2, we have two categories, male or female. So if you have n categories, then by knowing n minus 1 values, you can say what nth value is. So here we have two categories, then 2 minus 1 is 1. So by knowing just one column, male or female, whatever, you can predict other ones. So that's why we have dropped uh, first column, and this way this is my data set. So what I will do now, I will append this into my X. So from X I will drop this gender, and then I will append male uh, column. So this way I have dropped gender from X. So if you will see how X looks like, then I will show you here. X dot head, if I will do, then you could see X looks like this. So we have only age and estimated salary. Gender has been dropped. Now I have created that dummy variable. So that gender underscore dummy, that is the data frame. So I will append, I will concate both the data frame. So pd dot concate X gender dummy, X is equal to columns. So this way I have concatenated. So now if you will see how my data looks like, so this is perfect for the model. We have all the value in numbers. We have age, estimated salary, and this male, which was category dummy variable for categorical variable gender. So my input data set, which is independent one, so we have all the values in numbers. There isn't any null values. So now we can pass this directly into the data, into the model. So now model creation, model part will start working on. So here you could see from sklearn.model selection import train test split, because we will follow the same principle of train test split, 20% for test purpose and 80% data for train purpose. So X train, X test, Y train, Y test, these four data set will get created, and this is the standard syntax. Now, so out of this 400, if you could see how much is there in my train data set, then you will get the result here. So you could see we have 320 for train, and for test it should be around 80. So let me execute the code now. So now again we'll work on model part. So from sklearn.linear model import logistic regression. We'll use same package sklearn.linear model, and then this logistic regression, and this object of logistic regression I am creating model equal to logistic regression. Code got executed. Now I will train my model. So model dot fit, which is again a standard syntax, X train, Y train. So I am giving this input of training data set and this output training data set, and let's execute the code got executed. These are some of the parameter which are default parameter and used by this model. Now let's predict some data set. Now let's predict values using this trained model. So I have passed this test data set, and let's see what are the values for this predicted one. So these are, you could see some zeros and some one. And so logistic regression gives value in between 0 to 1, as you had seen in this example. So it gives value between 0 to 1, and based upon some cutoff it has been decided whether it's 0 or whether it's 1. So if you would want to see those values, so you could see this value is 0.74 and 0.25. So that's 0. Probability of buying insurance is 0 here because it's less than 0.5. And this most of these are less than 0.5, but some are more than 0.5. For example, this one. So for this you could see prediction is 1. If you would want to see the score, this gives R square score. Then let's execute this code, and you could see 78.75 percentage. So this means around 79 percentage of cases prediction is correct. So this was logistic regression part. So I will recap quickly. So we went through theory, and then in the data part, so main exercise, main data cleaning or data preparation steps that we need to do is we need to check whether there is any null values or not. In this case there wasn't any null values. Then separate output data set and input data set, that it separate output which is dependent in y and out input which is independent in x. So that was the second step. First step was null value check, second was x and y separation, and then third one is categorical variable to numerical variable using get dummies that I had done. So that was the third data preparation step. Fourth one is training and test split. So using train test split function of sklearn, we have learned that one. Once we prepared our data, then we created object of logistic regression, and using that dot fit we have trained my model, and then using and then model got, and then using dot predict we predicted values, and then this is the score. You could see 78.75%. So till here our exercise is finished. Just quickly going back to theory and trying to relate a relationship between this model which we have used directly, and trying to create equation based upon definition which we explained in theory part. So quickly I will say see coefficient. So since we have three variable in input data set, so here we have three variable: age, estimated salary, and male. So there are three coefficient which you could see here. These are the three coefficient, and then this is the intercept values. This is the sigmoid function that we have defined here, and then so this is 1 divided by 1 plus exponential of minus x. So this is the sigmoid function, and then this prediction function which we are defining here is three independent variable: age, estimated salary, and males are input parameter, and those coefficient which has been uh, trained by this model algorithm. So 4.51, 7.9, and this. So these three coefficient, using these three we tried to write equation of the line z equal to m1 x1 plus m2 x2 plus m3 x3 plus c, and that z I have passed to the sigmoid function, and this y thing we have calculated. So this way this prediction function is. Now I want to check values. So this age, estimated salary, and this male equal to 1. So this is from one of the data set. I will show you. So X test, so that was my test data. So you could see first Test data set was age 30, estimated cell 87K, and male equal to 1. And for that first row, prediction probability was 74.08 percentage for no and 25.91 percentage for X for yes. So let's predict for that line. So you can say exactly same value, 25.91 percentage for this yes thing. Now second line is 38, 50K and 0, and here prediction probability should be 48.70. So same thing I have passed here. So see 48.70. So this way we can say yes, whatever we got through model and same is coming through this theoretical equation. So this was just to explain you theory part. So that's it about logistic regression. Thank you.